Hi there, guys. All right, so at this point, you should be hopefully well into physics. You should be done your kind of unit conversions, and hopefully you've downloaded the notes and you're kind of ready to go. Okay, on this lesson, we are going to be talking about scalars and vectors and distance, displacement, and position. All right, starting with scalars and vectors. Basically, these are ways that in physics we kind of classify measurements as either scalar or vector. And the main difference is about direction. Okay? Scalars are quantities that do not have direction. Okay? They're just numbers. They still have units, but direction is not important to a scalar quantity. So these are things like speed, distance, time, volume, and mass. So for example, saying, you're traveling 15 meters per second, that's a scalar, but we don't know which direction you're traveling, okay? Saying something is, you traveled so far in 5 hours, again, there's no direction there, that's a scalar. So the opposite then is vectors. Vectors have an amount, but they also have direction. So the direction is going to be like north, east, south, west, right, left, up, down, something like that. Vectors are displacement, acceleration, velocity, and they will again have a direction. Now to indicate something is a vector, if you look at the bottom here, we use little arrows on top of the symbols to indicate that we're talking about the vector and not the scalar. So for example, the symbol for distance is a lowercase d. The symbol for displacement is also a lowercase d, but because displacement is a vector, we write it with a little arrow on top. Okay, this concept's going to come into play as we move through physics, because anything that is a vector, it's really important that in the answer, if you're given direction, you need to include that direction in order to get full marks and to, have a proper answer. Okay, so quick review here. Just simply labeling the following quantities as either scalar or vector. So it really just comes down to a definition. All right, number 1, the distance of 13.5 kilometers. That's scalar. There's no direction. Wind blowing 40 kilometers per hour northeast. That's a vector because it has a direction. A 50-liter tank of gas. No direction. Scalar. 16 years old, same thing, scalar. Car drives 80 kilometers per hour. That's a speed, scalar. Any mass is always scalar. So if we're talking about grams, kilograms, pounds. 25 degrees Celsius, temperature, scalar. And driving 30 kilometers due south, vector. So even though it's written in words there, it still has direction. So that's just kind of a term you'll have to kind of be familiar with as we move through. Okay, so a bit more on vectors then. Vectors, again, direction is important. Now, oftentimes throughout this unit, we're obviously going to be doing lots of calculations. And when we are kind of calculating or adding and subtracting, we need to have a way of indicating that direction in an equation. So we use typically positive or negative to indicate a direction. So there are proper sign conventions, which means they're kind of just the proper, well-known way to do things kind of in the physics world. So typically, the directions of up, right, north, and east are considered to be the positive directions. So in an equation, we would write those as positive. That leaves then down, left, south, and west to be negative. Okay. It is important that you're familiar with your kind of compass directions. So you should be aware of north, east, south, west. Okay. All right. That's basically scalar and vector. We'll work on it kind of as we go through the unit, but that's just the basic knowledge. All right. Then we have distance and displacement. Kind of two differences here. First one is simply that distance is a scalar quantity, which means direction is not important. Displacement is a vector quantity, which means whenever possible, direction matters. Okay, again, notice this little arrow on top of the displacement lowercase d to indicate that it's a vector. So vector and scalar is one difference. They also are conceptually a little different. When we're talking about distance, distance is referring to the total ground that the object is traveling. So let's say, you leave your home, you drive yourself to school, you stop to get lunch, and you drive yourself home. Okay? The total amount of ground you covered is the distance. Displacement is only about how far and in which direction essentially the start and the finish are. Okay, so it is just the shortest interval between the start and the finish. Oops, sorry, I messed up things here. Okay, so for example, if you drove yourself to school, stopped for lunch, came home, the displacement between where you started and where you finished is actually 0. Okay, so that's where conceptually distance and displacement differ. So let's look at the example here of this butterfly. Here we have a happy little butterfly, and he's flying around, and he goes from A to B to C to D to E to F to G. Okay, if I were to calculate the butterfly's distance, I would add up that entire journey. Okay, all of the curves and ups and downs that the butterfly took. Now, if I were to calculate the butterfly's displacement, notice this green line here is the displacement. Displacement is only the shortest interval between where the butterfly started and where he ended, but it's not necessarily the actual path that the butterfly traveled. Okay, so it could be a very different number than the distance. Okay, and again, because it's displacement in a calculation, we should have direction included. All right, so let's do another example with that. Imagine you went for a bike ride and you traveled from the tree A to the house B and then to the tree C. Okay, so typically use I as kind of the initial position and F as final. So we started at A, we ended at C. All right, distance then. Looking at distance, first we traveled 4 kilometers to the house, then we traveled 3 kilometers to the tree. Therefore, our distance was 7 kilometers. Now my displacement here, looking at my picture, displacement conceptually is the shortest interval between the start and the finish, which my picture shows me is 5 kilometers. And again, if we can include a direction, we should. So thinking about our compass here, northeast, southwest, that would be written as northeast. Okay, so it is important that you can, kind of using a picture or a representation, indicate the difference between distance and displacement. All right, then we have position. Position is also a vector quantity, and it actually has the same symbol as displacement. The difference is that if you're given the position of an object, that means it's describing the exact location of that object relative to a reference point. Okay, so for example, if the number saying person A is at a position described by -5, that's using 0 as a reference point. So that is the exact location of that person. That's different than just saying, person A walked, 5 meters left, because that's not necessarily saying a position, that's describing movement, but we don't know in relation to what reference. Okay, so when the word position is used, it is kind of using like a 0 as a reference point. Okay, now oftentimes with distance, displacement, position, it is really helpful often to draw yourself a little picture or a number line to help you picture things. Okay, I'm going to stop this video here, and then I will do another one on formulas, but feel free to stop down and do a couple questions in your workbook before moving.